Assalamualaikum warahmatullahi wabarakatuh. Good morning and greetings to all of us. On this happy occasion, we group 3 will present about carbon management in the coal industry. But before that, I will introduce our members. There is me, Muhamad Mahfud Muzadi, with student number 19, Ladunia Rahmah with student number 1, Siti Salwa Azzahra with student number 2, Tasya Larasati with student number 11, and Dimas Abiswara with student number 65. Okay, next. This is an outline of our material. The first is about introduction, and then the coal industry processing and carbon dioxide emission. The next is the treatment and separation of carbon dioxide in syngas or full gas, and then the recycling and carbon dioxide application, and the novel sorbent and membrane separation, current research and development. And the last is about conclusion. The first is introduction. One of the issues that is trending is the addition of greenhouse gases, which causes global warming. Without greenhouse gases, the earth will be too cold and become an uninhabitable place. However, if there is too much CO2 in the atmosphere, global warming will occur. As a result, high sea levels can drown small islands, drought and floods, and so on. Here's the before and after picture of the melting of glaciers after nearly a century. You can look the screen. Apart from having an impact on the environment, CO2 emissions are also dangerous for humans. The limit of exposure, according to the American Conference of Governmental Industrial Hygienists (ACGIH), is 5,000 ppm in 8 hours. Concentration above 40,000 ppm will cause symptoms of poisoning, and prolonged exposure will be life-threatening. The coal industry is one of the largest contributors to carbon dioxide emission for its unit of energy produced. Due to its high carbon content, coal accounts for about 44% of global CO2 emissions. In addition, according to an International Energy Agency research, there was an increase in CO2 emission figures from 1971 to 2011, which are shown in the following graph. Based on the description above, carbon management is an important aspect in the coal industry. This is because coal releases the most carbon dioxide per unit of energy produced and has a negative impact on the environment and people. For this reason, this presentation will explain about carbon management in the coal industry.
And the next is coal industry processing and carbon dioxide emissions. Coal is an important source of energy, and the reliance on this fossil fuel for electricity generation is growing. The combustion of coal adds an amount of carbon dioxide to the atmosphere more than does the combustion of other fossil fuels. Because of a growing concern over the possible of global warming, a phenomenon characterized by an increase in surface temperature, Earth is caused by increasing levels of greenhouse gases. And this table is emission factors for faint, flight, and fugitive carbon dioxide and methane. There are two kinds of ways of calculating the amount CO2 emissions, namely calculation based on a stoichiometric reaction and a mass balance process. And this picture explain about mass balance scheme. And the next is there are various ways to process coal before combustion to produce energy, namely first PCC. PCC or pulverized coal combustion is a well-developed technology for coal-powered generators. There are many of its kinds implemented around the world in developed and developing countries. Pulverization is need to maximize the surface area for combustion. And the second is IGCC, Integrated Gasification Combined Cycle, is a less developed technology compared to PCC, but the benefits to the environment by IGCC are far greater. The following will give a description of the gasifications of coal and the idea behind a combined cycle. And the third is FBC or fluid bed combustion. FBC is typically implemented with PCC, IGCC, or oxy-fuel combustion to improve combustion or oxidation reactions. FBC is a cleaner method of combustion, but it sacrifices efficiency because of its low operating temperatures and the energy needed to fluidize the bed. Furthermore, due to low combustion temperatures, there is no formation of nitrous oxide. FBC technology is also beneficial because it can use a variety of fuels such as low-grade coal, biomass, or waste-derived biomass fuels. And the last method is oxy-fuel combustion. While PCC and IGCC technologies require the separation of CO2 from the flue gas or syngas stream, oxy-fuel combustion is unique because it produces a highly pure CO2 that will require little or no separation. Rather than combusting coal using air, oxy-fuel combustion drives toward complete combustion by feeding pure oxygen into the combustion chamber. Thus, the reaction products will be water vapor and CO2.
The next material is about treatment and separation of carbon dioxide in syngas or fuel gas. Carbon dioxide gas is an important gas for living in the earth. For the example, carbon dioxide is important for plants because plants use the carbon dioxide as raw material for photosynthesis. Carbon dioxide gases gives 50% contribution in global warming, then the other gases like CFC, 20%, CHT, 15%, ozone 8%, and NOx 7%. The content of carbon dioxide have the time to survive in the atmosphere for 50 until 200 years in the atmosphere. Carbon capture and storage or CCS is the most indicated technology to decrease the amount of carbon dioxide emission from fossil fuels, and carbon dioxide separated from flue gas can be used in enhanced oil recovery. Carbon capture and storage or CCS consists of the three basic stages. The first one is separation, transportation, and storage. The separation include pre-combustion capture, oxy-fuel process, post-combustion capture. Pre-combustion capture, including the reaction of a fuel with the oxygen or air and produce a gas, mainly consists of carbon monoxide and hydrogen, which is known as synthesis gas or syngas or fuel gas. It is only used for IGCC or integrated gasification combined cycle process and is typically less energy intensive compared to post-combustion capture. The disadvantage of pre-combustion is a system needs long-term development in a number of enabling technical areas of achieve target efficiency towards a hydrogen economy. The second is oxy-fuel process. In oxy-fuel combustion, pure oxygen is used for combustion instead of ambient air, and this results in a flue gas that mainly consists of carbon dioxide and water, which are separated by condensing water. And the last is post-combustion capture. The post-combustion capture is carbon dioxide separation from flue gas combustion. The carbon dioxide in flue gas is diluted with the inert gases such as argon, nitrogen, and water in addition to oxygen. Post-combustion capture doesn't require expensive technology. The next material is about recycling and carbon dioxide application, will explained by Dimas.
The next is recycling and carbon dioxide application. In its recycling and application, after it's been stored, carbon dioxide can be used directly or transform it into fuel. In direct usage, carbon dioxide can be used in liquid state with a liquefaction process as a main compound in fire extinguisher, and in solid state with a deposition process to change it into dry ice, and also directly used in a gas state as an injection in enhanced oil recovery process at the crude oil industry. Then carbon dioxide also can be transformed into fuel with a methanation process by reacting it with hydrogen compound. Therefore, it will form some methane and water as the result. It also can be transformed by using artificial photosynthesis process that perform in an algae to transform it into biomass fuel such as isobutyraldehyde and isobutanol.
The next material is about novel sorbent. The first one is zeolite. Zeolite is the aluminosilicate with the structure of cavity crystal, which contains metal ions and water molecules which can serve as a physical adsorbents. From the table, it's shown the zeolite 13X produced the adsorption capacity of 2.5 until 3 mol CO2 per kilogram at ambient temperature, while at temperature 350 degrees Celsius, the capacity decreased to 0.01 mol per kilogram. In the simulation, the comparison of the use of Selexol chemical and zeolite produced a comparison of the efficiency of 36.6% and 37%, where the use of zeolite as adsorbent is more effective than commercial adsorbent. The next is about metal hydroxide. Metal hydroxide is the hydroxide of the metal which are known as strong bases. Many kinds of metal hydroxide is made from hydroxide ion, FeOH2, NiOH2, COOH2, and ZnOH2, where the lack of metal hydroxide is the price very costly and easily degraded by water vapor. With the comparison of the Selexol with metal hydroxides can be seen that the Selexol is more efficient than the metal hydroxide with the difference efficiency of 0.6%, which is the use of metal hydroxides can still be said to be efficient, with FeOH2 is more efficient than other metal hydroxide. The next is about membrane separation. The use of membranes for gas separation are very promising in the field of research because it is a compensation for the problems associated with the process of MEA or process Selexol at this time. The energy load from the capture of carbon is much less than previously discussed methods because the membrane doesn't require heating intensive and cooling. The challenge faced by the membrane is the difference in the large degradation at a high temperature and reaches the performance of purity. From the membrane separation, the first one is pre-combustion membrane capture. Pre-combustion membrane capture of CO2 is considered as a promising option to reduce environmental pollution from burning coal, because the energy required is relatively low and the prospect for use of hydrogen in power generation and industrial sectors. From the diagram below, we can see that syngas out of the reactor, the WGS consists of H2, and CO2 at high temperature and high pressure. This is because the metal or inorganic materials are thermally stable when operating at temperature above 300 degrees Celsius. The use of membranes allows the separation of CO from syngas produced by gasification. During this process, the legend is divided into the flow of H2 and flow of CO, at which point the flow of H2 proceeds to the gas turbine, while CO is converted to CO2. The next is post-combustion membrane capture. Post-combustion process to treat the gas flow of the flue which has low pressure and the CO2 content is low, diluted with nitrogen. The advantage of the choice of post-combustion is the principle can be applied in the source of any emission. For the example of power generation, cement, and steel plant, and then petrochemical plants, including retrofit. The solution is to implement a process of multi-stage. However, the problem with the membrane of the multi-stage is that capital and operating costs will be much higher, because recompressive pump should be installed between the membrane units. The next is membrane contractors. Another use for the membrane is the adsorption non-elective and non-reactive. This improves the absorption of the gas liquid so that the size of the facilities of the areas will be smaller, then the price is cheaper. Now operating system single membrane curing because the technology can handle the volume of gas. However, a hybrid system such as the use of contractor membrane with adsorption can be alternate additive to process of carbon capture in conventional.
And the last is conclusion. Carbon dioxide emission that came from coal industry is getting higher nowadays because their slow to degrade characteristic and its use is increasing, make carbon dioxide pile up even more. To manage it, the carbon dioxide is being captured after it emits and stored in the storage. This process needs a good separation in order to maximize the capture of carbon dioxide, such as membrane separation in post and pre-combustion. After carbon dioxide is being stored, it can be used directly or even getting more process to convert it into valuable products such as fuel with a methanation process or artificial photosynthesis. This conversion can increase the selling price of the product, so that this process can bring us more benefit and profit and also for the world. Thank you. That's all from our group. We're sorry if there's some mistake in our presentation. Wassalamualaikum warahmatullahi wabarakatuh.